Good afternoon. Your attention is presented to the work optimization of the composition of cement composites. Authors Tatiana Ilchisheva, Ekaterina Abramova, Irina Yerofeeva, Viktor Afonin, Vladislav Moiseev, and Alexei Atmanzin. The work was carried out at the Tambov State Technical University Tambov and the Ogarev National Research Mordovian State University Saransk. 5 samples were tested at each of the 9 points on a response surface for a total of 45 samples. The coefficients of equations are calculated and the regression equations are obtained. Based on them, graphs of the dependence of the compressive strengths and bending strengths are constructed in the form of surfaces, which are points or the value of the response function for 2 variables, the amount of additive introduced into the composite material. Experimental studies have shown the preference for using compositions that contain from 3 to 6 parts by weight of sodium sulfate and from 6.5 to 13 parts by weight of the dispersible powder by weight of the cement. Figure 2 shows line diagrams of equal influence of response functions, with compressive and flexural strengths of at least 85%, 19%, and 95% of the maximum compressive and flexural strength function. In Figure 3, the shaded areas guarantee compressive and flexural strength values of at least 95% of corresponding maximum compressive and flexural strengths. The choice of factor values from the optimal areas is carried out visually according to the diagrams and programmatically based on the properties of the patch function of the MATLAB system. The slide shows a list of materials and research methods used. For planning experiments on the manufacture of cement composites, a 2-factor Kono plan was adopted. The following components were used to make a composite: Portland cement without mineral additives, quartz sand, sodium sulfate, dispersible powder. Fungi resistance and fungicidal activity were determined according to GOST 9.049.91. Unified system of protection against corrosion and aging. Method 1 allows you to determine whether there are food sources for micromycetes in the building material under study. Therefore, infected samples were placed in petri dishes with distilled water. Fungus resistance was rated from 0 to 5 points. The material was considered to have passed the test if its fungus resistance is no more than 3 points. When tested according to the method 3, infected material samples were placed in petri dishes with DAPAC nutrition medium which feeds mold spores. Method 3 determined whether the building material has fungicidal properties. Strengths were determined according to GOST cements test methods using polyfractional sand and GOST concrete methods for determining the strengths in control samples. The optimization problem was solved using the global search MATLAB system. The purpose of the work was to optimize the compositions of cement composites and to identify the optimal concentrations of sodium sulfate additives and the dispersible powder, which improve the consumer qualities and composites and only slightly reduce the strength properties. To achieve the goal of the work, it was necessary to solve the following tasks: to make samples of the control composition and with modifying additives, determine experimentally the compressive and bending strengths of samples of cement composites, determine the biostability of composites in natural and aggressive biological environments, suggest an approach to optimize the composition of cement composites and identify the content of additives, which increases their consumer properties and reduces the compressive and bending strengths slightly. The properties of cement composites were studied with introduction of a biocide additive and their dispersible powder in accordance with the 2-factor Kono plan of the second order. The variable factors are the addition of sodium sulfate, this is the factor x1, and the addition of a dispersible powder is the factor x2. Table 1 presents the result of studies of the strengths and fungi resistance of the material. The solution to the problem of determining the optimal composition of composites was based on regression equations. Table data were used to convert the actual values of factors to coded values. Coded values are presented in Table 2. The methods of searching for the global extremum were applied over the entire domain of definition of the regression equations. The analysis of the tensile strengths by regression equations consisted in a choice of the method and algorithm for searching for the global extremum. The solution of this problem was carried out using the Global Search Toolkit of the MATLAB system. The stages of the study were as follows. The extreme values of the strengths and the corresponding values of factors x1 and x2 were determined. Lines of equal influence were built, the values of which corresponded to a given percentage of the levels of maximum strength values, using the contour-Clapeyron functions of the MATLAB system. The mesh grid and mesh functions were used to visualize the response surfaces of strength values. Lines of equal influence levels were plotted separately using the contour, Clapeyron, line, patch, x-label, y-label, legend, and title functions of the MATLAB system. The patch functions was used to fill a closed figure on a plane. The resulting figure is lines of equal influence. The entire shaded area ensures that the strength value is the required percentage of the maximum values. The coordinates of the points of maximum values of the functions are included in these areas. The results of calculating the points of intersection of the values of factors with equal percentage of the maximum strength levels are given in Table 3. The boundary interpolation curve and the range of values that guarantee the compressive and bending strengths is the range from 85 to 91.5% are shown in Figure 4. As a result of the study, optimization criteria were established. The sequence and scheme for selecting the optimal composition of cement composite materials containing modifying additives were presented. The concentration of modifying additives has been revealed, which makes it possible to achieve the required properties of the composite, guaranteeing a decrease in strength by no more than 9.5 to 15% of the initial values. The indicated concentrations were sodium sulfate from 0.83 to 5.43 parts by weight of cement, and redispersible powder from 0.95 to 6.80 parts by weight of cement. The developed scheme allowed you to determine the optimization criteria for any number and modifying additives and the level of required qualities of compressive and bending strengths. A promising direction in the production of building materials is the introduction of dry building mixtures on a cement binder into the construction technology. They have advantages over the use of ready-made mortars and concretes. Mixes allow to improve the quality of construction, labor productivity, shelf life of materials, to refuse the use of special equipment for the delivery of dry mixes, to provide the construction organization with mixtures for a long time. In Russia, dry building mixins were introduced into construction practice at the end of the 20th century. To improve consumer properties and improve physical, mechanical, and operational performance, modifying technological additives are introduced into dry building mixes. The paper considers the introduction of two types of additives for special purposes in the composites. These are sodium sulfate additive to improve biocorrosion resistance and neolith P8800 redispersible organic terpolymer powder additive to improve adhesion. The introduction of additives can not only improve but only worsen some indicators of cement composite materials. Therefore, together with experimental studies, it is necessary to solve the problem of optimizing the composition of mixtures. The regulatory documents that define the properties and test methods of dry building mixtures and additives in the Russian Federation are the following documents presented on the slide. GOST, dry construction mix based on cement binder, general technical conditions. GOST, dry building mixes based on cement binder, test methods. GOST, additives for concrete and mortars, general technical conditions.